Let's begin. Okay, do 1 through 3. Okay, and so kind of from here on out, we're reviewing for the mock exam. We're going to break it up into 3 sections. So we'll do derivatives and limits. Then we'll do a section on just derivative tests, related rates. Then we'll do one on integrals. And then the AP test will be here before you know it. And you'll get free days for the rest of the year after that. Okay, so May 14th is D-Day, and then after that, you can chill. Okay, that's when the AP test is.
It's not far from now.
Exactly, that's what I
Wait,
said. Yes.
17 days.
It's a Tuesday.
It's scary, bro.
It could be, mine's in the morning, so AP Bio might be in the afternoon. Yes?
Wait. No, if I was Monday.
Oh, okay, it's Monday. She was the one who said it was Tuesday.
Hold on, I'm gonna have like 2 exams on 2 days.
Yeah, might happen. Just by the exam, or the day of the exam.
On Monday I have 8 o'clock.
No, you come to normal classes.
Okay,
Okay, Salama, did you have a question? It's at 8, and it's in the lecture hall. Yes, okay, listen. Some of y'all are asking the same questions twice, so everyone listen at the same time. Mock exams tomorrow at 8 till 12 in the lecture hall. There will be no more after-school study sessions after the AP test. So if you haven't already done them by the date of the AP test, it does not help me for you to review after you have already gotten a 1. So if you don't do them by the AP date, you're taking the exam or you're exempt. Those are the only 2 options at that point. Okay, so I want you to do the study sessions to make you not get a 1. If you don't do them, they're right there. I think there's 6 left, but you can make up ones you've missed because I've been videoing them. Okay? Yes. Yes, you have to come in and get the packet from me and do it in my room, but they're all online. No, that doesn't help me. Okay, ready? Do 1, 2, 3. You can do it. 1, 2, and 3. What does the cuss mean that it's not? Okay, B is not, remember it says it has to be continuous, so if there's a hole, that counts as nonsense. Continuous means you can draw it without picking up.
Without picking up a pencil.
Yep. So guys, remember that continuous means that it doesn't have a hole, right? Like that you can draw it without having to lift your pencil and keep drawing. So if there's a hole, that doesn't count as continuous. It is, yes. Okay? And you can work together, okay, that's fine. Differentiable means it's smooth. So like it can't have any cusps, corners, sharp turns, it can't have any vertical tangents. That also counts as non-differentiable.
Also like C.
Do you mean
Right here.
Right there, so it's not
But like this sort of different. Help me look up in the
I feel like the whoa should be more like a whoa, like a horse. In my opinion. Like when you're trying to hold it, like, you know, and you're like, whoa, boy. Whoa! That would be a way better
That's
whoa.
like, no.
In my opinion.
C would be continuous and differentiable, right?
Because what's the differential means there's a slope. What's the slope if it's like that? Yes, but the slope would be here. Because it's like, oh yeah.
Right, if you have a number and you plug it in, you can plug it in, but if you get 0, then you have to do like that rule.
Okay, yes. So guys, number 1, have we chosen an answer?
You already told us A.
I did. Well, I think I secretly said it, but now I'm publicly. Oh, I did? Okay, it is A. Okay, remember, because if there's a cusp, That means that it's not differentiable. What else qualifies as not differentiable? Okay, a corner. Okay, if there's a break in the graph, like if it's not continuous, that would also count as not differentiable. The other thing is that if there is a vertical slope, that also counts. Now that doesn't happen here, but you should know that if it did, that would also count. So I'm going to put vertical slope. Okay? But A is the correct answer. Okay, go to number 2.
4/3.
What? It is. Okay, so there are 2 ways. Okay, listen, there are 2 ways to do number 2. The first thing that you should try is to plug it in. For my people that have already done that, when you plug it in, what do you get on top?
0.
What do you get on bottom? 0. Now remember, if you get a number on top and 0 on bottom, that means the limit doesn't exist. If you get a 0 on top and a number on bottom, that means that it's 0. No, so if it's like this, look. Number over 0 is DNE. But 0 over a number is 0. Because think about, can you divide 0 by a number? Sure, you get 0. Okay, but if you get 0 over 0, that means you can either do L'Hopital's rule or you can factor cancel. If you suck at factoring, do L'Hopital's rule. If you don't suck at factoring, then you can factor. Okay, so look at number 2. How does the top of that factor? Okay, good. X approaches -5, x plus 1, and x plus 5. Okay, on the bottom, I need numbers that multiply to 10 and add to 7. X plus 2 and x plus 5. And then from there, if my x plus 5s cancel out, I can plug in to what's left over. So what's left over would be -5 plus 1 on the top and -5 plus 2 on the bottom. -5 plus 1 on top is -4. On bottom, I get -3, which is going to be 4/3. Now, keep in mind that you can only do that if you get 0 on top and on bottom. If it's only 0 on top, the answer is 0. If it's only 0 on bottom, it's DNE. Okay? All right, so one other thing I want to remind you of before I give you another couple minutes to try number 3. What does 2 give you in the graph? Do you remember? Vertical asymptote. What does 5 give you in the graph? A hole. And so remember the difference? If there's a hole, that's why this limit still exists. Because both of your sides are approaching the same hole. Does that make sense? Versus for an asymptote, you don't have a limit. Okay, so now do number 3.
So these asymptotes are going to be on the bottom, and then holes are the center.
Yes. Okay, so it's like this. If it's on the bottom and it cancels, then it's a vertical asymptote. And then if it does cancel, then it's a hole. And that means that the limit still exists.
Wait, so does that mean like -2?
Yes, the asymptote's at -2. And then the hole is at -5. That's why when we did the limit, as x approached -5, we got a value. Because both of your sides of your graph are approaching that same open circle.
Why is it like bottom and cancels if the x plus 2 didn't cancel?
So it has to be on the oh, and it doesn't. Thank you. And doesn't cancel. Thank you for fixing that. So if it's on the bottom and it doesn't cancel, it's an asymptote. And if it's on both and it cancels, it's okay, you're doing it. We're reviewing. Okay, next one. Keep going. Why stop there? Okay, if you finish 3, keep going, people. Don't stop. Okay, so you're going to factor that. And then look for what doesn't cross out.
It doesn't have an equal in the middle, right?
Yeah, you're right. Miss, is that another high school?
Okay, listen. Boutiques tell us we're all sitting like black. So when I snatched the shirt, I didn't realize it was to my old school.
No.
So I was just kind of hoping, since it was in Spanish, no one would notice.
I speak Spanish.
I know, so it's unfortunate for me.
The name's also in English.
Yeah, hey, but who looks at that? Besides you, right now.
I speak Spanish.
Yeah, but did you notice I was wearing a co-teacher?
Negative 2 and
My favorite friend.
You can't see it's always on there.
I think it's just negative 2.
You know, what can you do?
This would be a
Okay, so top of this one. Okay, you should have gotten x plus 4 and x minus 1. On the bottom, you should have gotten x plus 2 and x minus 1. Did you get it? Okay, so then the vertical asymptote is the one that does not cancel. So it would be, is it E? B. Did you say B and I heard you wrong? Okay. Okay, keep in mind it's x equals. Question, what type of asymptote are y equals? Okay, these are horizontal asymptotes if they're y equals. And how do you find horizontal asymptotes? Good.
Wait, so those are from the numerator? The horizontal?
Well, it's a combination of both. You're looking at the powers to see which one's bigger. Okay?
But vertical is always the denominator.
Correct. Eileen, yes? It is. Well, so keep in mind that if the bottom is 0 but it cancels out, then it creates a hole in the graph. That's the difference. So if it doesn't cancel out, it gives you an asymptote. But if it does cancel out, it just gives you a little open circle, but it doesn't change the shape. Okay, next one, number 4. Okay, maybe you already tried it, maybe not. Okay, how does the top of number 4 factor?
X plus 2.
Okay, they can't both be plus.
What was it? X minus 2.
Okay, good. So x approaches. Okay, are you guys ready?
Yeah.
Okay. So we want a plus 1 in the middle. So we need our 3 to be positive and our 2 to be negative, yes? Okay, on the bottom, you have a 2 minus x. Okay, these do not cross out as they are. How? Good. Do you really remember that? Wow, great. Okay, I'm going to factor out a minus 1. And then that's going to make those match each other. So look, watch. I'm going to keep the top the same, plus 3 and minus 2. But then on the bottom, I'm going to take a negative 1 out, and it's going to fix it to where they match. So my 2 divided by a negative 1 is now a minus 2. And my x, factoring out a negative 1, becomes a positive x. And now I can factor them out and cancel. So these guys are both going to be gone now that they match each other exactly. And then what was x approaching? 2. So then I would take my 2, plug it in here. 2 plus 3 is how many on top? 5. And then over negative 1 is negative 5. Good.
Does it matter whether you factor out the negative on the bottom or the top?
It does not matter. Okay? Alright, 2 more left. Number 4. How are you going to factor number 4? That's only if x is going to infinity. You're approaching 0. It's the greatest kind of factoring. It's the greatest common factor. Okay, and then in number 5, there's another special type of factoring. You remember difference of squares? Okay, so do those 2 and then we'll turn the page. Okay, what can we take out of number 4 from the top? X squared. What's going to be left over? 5x squared plus 8 on the bottom. X squared comes out again, and what's left over? 3x squared minus 16. Now keep in mind that x is approaching 0. So the reason I can't plug in 0 right off the bat is that I get a 0 on the bottom and on the top. So when I cross these guys out, gone, because I ended up with an x squared and an x squared, then what's left over, I can plug 0 into that. Okay? So I'm going to have 5 times 0 squared plus 8, and then 3 times 0 squared minus 16. What do we get on top? 8 over negative 16, which reduces to negative a half. Good. Okay, now let's say that factoring is not your thing, and maybe you suck at it. Okay? The other method that I mentioned is L'Hopital's rule, but I want to remind you of how to show your work on it if it's free response. If it's multiple choice, obviously they're not going to care, but let's pretend like this one's free response because we're about to do it on the back. The first thing that you have to do to use L'Hopital's rule is show that the limit on top and on bottom both come out to be 0 separately. So, when I plug in x approaching 2 on the top, I have 2 squared minus 4, I get 0. When I plug in x approaching 2 on the bottom, that'd be 2 minus 2, I get 0 again. And when you show that both of those one-sided limits equal 0, then you can do L'Hopital's rule. Remember, L'Hopital's rule says this: you can take the limit as x approaches 2, and then take the derivatives, top and bottom. Okay, what's the derivative of x squared minus 4? 2x. What's the derivative of 2 minus x on the bottom? Negative 1. Then plug in x approaching 2. You get 4 over negative 1, which is negative 4. Okay, that's L'Hopital's rule. Could you have also done this by factoring? Yes. Do it by factoring, confirm that you still get negative 4, and then turn the page. Yes. So you would have to do L'Hopital's rule twice. Did you do it twice? Because think about when you take the derivative, you get 20x plus 16x. You plug in 0 on top, and you get 27. And then on the bottom, you would have 12x minus 32x. Plug in it, you get 0 again. And you're doing negative 1. So that's what I'm saying. It kind of depends. You're going to have to do L'Hopital's rule several times, then factor cancel. So when I plug in, I get.
Just if I like bring that as well. Okay, so
You can get the limit to figure out the say no. So what's the derivative? Yeah, and you're not using the rule that sometimes when people use L'Hopital's rule, you're taking the limits on separate. And then you're taking their derivatives. But you can also factor Okay, turn the page.
We saw homework.
That one you're not doing.
Miss, you're in Spanish club?
I was the sponsor for Spanish Club at Poteet. Yeah. It's pretty great. So you have one homework and then one note. So you only have 3 homeworks. One's on limits, one's on derivatives, one's on integrals. It'll just be due by the AP test. And I'm going to send out the answer key so you can check your work. Okay, so L'Hopital's rule up here at the top. Okay, you should have noticed that the next 2 come out to be 0 over 0. Now, let me say this before we do it. If you're good at factor cancel, L'Hopital's rule can work limits that factor cancel cannot. Factor cancel will not solve all your problems. L'Hopital's rule will always be able to do it. So if you're going to pick only one to learn, you need to pick L'Hopital's rule. Because if it's not factorable, a lot of times L'Hopital's rule can still fix it. And if you haven't taken your mock exam, there was a question on the FRQ that we're going to look at that involved that. Okay, so If the limit as x approaches a of f of x is 0, and we're writing out the rule, the limit as x approaches a of g of x is 0, then the limit of f over g is equal to the limit of f prime over g prime. Okay? Now, this is already in your notes somewhere, but the reason that we're writing it out is to remind you that it's a theorem. You have to show that you can use the theorem before you use it, if it's free response. If it's multiple choice, nobody's ever going to know if you proved it or not. But in practicing for the FRQ, we're going to do number 6 the long way again, just to remind you of the steps. So, if the limit for f is 0, and the limit for g is 0, then the limit of f over g is equal to the limit of, this says f prime over g prime. Okay? So I'll actually maybe do number 7 with you, and then you can go back and do number 6. Okay, so look at it. First thing I'm going to do is find the limit as x approaches e of ln x minus 1, and the limit as x approaches e of x minus e. So notice, this one is the top, this one is the bottom. Now, when I plug it in, I get ln of e minus 1. But what's the ln of e? 1. And what's 1 minus 1? 0. Okay, then on the bottom, I plug in e. What's e minus e? 0. Anytime that the limit for the top and the bottom are both 0, you can take the limit of their derivatives. So look at the first one. Okay, if I want the derivative of ln x minus 1, what's the derivative of ln x? 1 over x. What about the minus 1? Derivative is 0. Okay, good. On the bottom, what's the derivative of x minus e? 1, and then e is a constant. So remember, when you take the derivative of a constant, it's what? 0, right? And then x is approaching e still. So I take the derivative of the top, I get 1 over x. Take the derivative of the bottom, I just get a 1. And then I take my e and plug it in. Well, then what am I going to get? What is that the same as? Which one? 1 over e. Good. Answer choice B. Only y'all could be. That's great. Hopefully you don't cut that score in half and each get a 2.5 and fail. That wouldn't be good. I don't know. Yes.
Isn't there like what's the ln that equals 0?
ln of 1 is 0. Because remember, for e, it's 0, 1. For ln, it's 1, 0.
So ln of 1 equals 0?
Yes. Okay, take a look at number 6 right next to it. Have you done it already? Okay. And then 6, 8, and 9. 8 and 9 don't require L'Hopital's rule, but I want you to try them. 8 and 9. Okay, you're going to have to think outside the box. You're going to have to try to fix it, but it's not L'Hopital's rule. 6 is, but 8 and 9 aren't. Yeah, the derivative of e to the x is e to the x again. Derivative of ln x minus 1.
Does not exist. None of these.
Yeah.
Wait, what if it's like e to the 2x, the derivative is 2, e to the 2x?
Yes.
That changes.
Okay, you gotta try to fix it. Number 8 exists. You just gotta do some stuff. Okay, think. When you have an x outside a set of parentheses,
I guess it
try to
exists and it's not
distribute, because what's going to
0, 1, or
happen? X
2.
times e to the x is 1, but then x times 1 over x, what happens? You just get a 1, and then the x isn't on the bottom anymore, and it kind of like fixes the problem. Try to distribute the x from that. So it'll be, so just be, you have to do these talks. You don't want to switch the days.
Was Jordan, did you say you use L'Hopital for Annabelle?
Not L'Hopital.
Oh, I just said try it anyways.
We'll try something else. We'll try a different method.
I'm tripping.
I don't know. What other methods are there?
Simplify.
It's I'm learning new things.
This is why. If this is a 1 over x,
We get one.
no, don't square. Okay, x times e to the x is just x. But then what's x plus 1 over? Okay, if you're struggling, think about what part of this, on this one, what was the answer? Was it 1?
Yes.
It was B? Okay. Alright, number 8. The problem is that when I go to plug in 0, I get a 1 over 0 right here, and that doesn't work. Now, why can't you use L'Hopital's rule? Because it's not a fraction, right? This part is a fraction, the whole thing is not. So, what I would recommend here is to distribute. This is why. This limit is equal to, what is x times e to the x? X e to the x. And then what is x times 1 over x? Now it's just a what? Now it's just a 1. These guys are going to cross out. And now, do I still have an x on the bottom creating this problem where I have a 1 over 0? No. So this is x e to the x plus 1. And then I take my 0, bloop, plug it in. Now, what is e to the 0 times 0? 0 plus 1 is 1. Good. So remember, factor cancel is a type of simplifying, but there are other ways to do it as well. Okay, go down to number 9. Do you remember how to do inverse trig?
No.
Okay, that's okay. So you're going to have tan inverse of 1 over sine inverse of 1 plus 1. Okay, now, I'm not going to do this one for you because I want you to try it, but I'm going to do a couple little, okay, good. Okay, pretend like it's this. Sine of root 3 over 2. Okay, I'm giving you a different one to help you do these in a second. I want you to tell me the angle where sine will be root 3 over 2. So think about it. If you do hand trig, my sine fingers are on the bottom. I want 3 of them. 1, 2, 3, fold it down. What angle would that be? Pi thirds. So you're going backwards. You want tan to come out to be 1. Find the angle. Then you want sine to come out to be 1. Okay? Yes, good. Okay? So if you didn't hear what Yoel just said, if I want tangent to be 1, tangent is sine over cosine. If those are going to divide to be 1, they have to be the same. So which finger are your sine and cosines going to match each other at? This one, which is pi fourths. So we have pi fourths over blank plus 1. Now, think about for sine. Where are your sine fingers? Top or bottom? Bottom. So I want all my fingers on bottom. Which finger do I want? It's not even really a finger. It's your thumb. And what angle is this? Pi over 2.
How do you know that?
How do you know that this is pi over 2?
Yeah.
Well, did you do hand trig? Remember, I taught it
I
to you.
came in like a week after.
We'll review it sometime. You could also do the unit circle, though, if you understood that better.
It's hard for me.
Okay, now, from here, I'm going to tell you what to do, and I want you to try to do it.
Student algebra teacher last year.
Okay, listen, this is the answer, but it's not one of the answers they gave you, so you need to make your answer match one of these answers. Here's what you need to do. I'm going to tell you, but I'm not going to do it for you. I need you to get a common denominator and then multiply by the reciprocal. Try it. So get a common denominator on the bottom, turn those into one fraction, and then you're going to flip it. Okay? You can do it. I'll do it for you in a minute, but try it on your own. That is perfect. You're almost there. Almost there. Get a common denominator on the bottom.
Wait, as what?
So like if it's pi halves plus 1, how could you change that to that 1 to be 2 over 2? Okay, so look, so I have this.
You keep the pi over 2? Like the
Uh-huh. Yeah, so look, so you're going to try to get a common denominator here on the bottom. So it'll be pi fourths on top. And then my pi over 2 needs to have a 1 that's compatible with it. So how could I rewrite 1 as a halves? 2 over 2. Okay, so if you need help, I'm going to do it up here. Okay, 1 is the same as 2 over 2, right? Now combine these guys into one fraction. Now they have the same denominator. So I have pi over fourths divided by pi plus 2 over 2. So far, so good? Pi over fourths, we're just leaving it alone for right now. Okay, the bottom, I changed 1 to a 2 over 2. Then I combined it into a single fraction. Now, why did I do that? So that I can flip it and multiply by the reciprocal. So I have pi fourths multiplied by 2 over pi plus 2. Now, the 2 over 4 can reduce to a half. Very good. So you have 2 ways to do this. Okay, 2 over 4 you can reduce to 1 over 2, which is how I'm going to do it. 1 over 2. And then from there, keep in mind that this pi plus 2 is all multiplied by that 2. So I have 1 times pi on top is pi, and then I have 2 times pi plus 2 on bottom. And that is the same as e. Okay, that one was a little bit tricky though. Alright, turn the page. So our goal is just to finish this page and then we're going to stop. So the torture is almost over. Okay, and then you have a nice weekend to take a mock exam for some of you. Okay, so have fun. Okay, do your last little set of questions. Okay, will a cookie make your day better? Come on. Focus.
I know.
I want to know how much I've spent on cookies.
Yeah, like right off.
You know, I wish I could.
Why you get any other flavor than
So they used to give money for star tutoring for them to get snacks, and I asked for it, and they said no. And I was like, y'all are
But they
greatest.
pay for the pizza, right? Like for the
They did bigger.
That's all
Do you have a Chewy toy?
I do.
Chewy Chick-fil-A are not better than the regular.
Okay, I have both of
Alright,
them, so
there's
no
so
worries.
many.
No, they're not.
Okay, you're only receiving this cookie as a contractual agreement to do the legislation. If you receive the cookie, huh?
Is it fun to have your cookie fall apart every time you bite it?
Bro, I was just thinking that.
Oh, you're throwing shade at the.
Original?
I was like, I'm not gonna make your cookie eating regular chewy. Yep. Whenever somebody says chewy, I want to go.
I think it just
Chewbacca.
You want a Chewbacca
I don't
cookie?
think it exists. You're right. This one does make sense.
Yes.
Not expecting that.
You picked a chewy cookie. Get it? Chewbacca. What's the big Chewbacca?
So much better.
Here you go. You guys want a cookie? I do. If you'd like, I can get those.
It's like from the left one. You get the left, the right answer.
Test 2.
Okay, right after this one.
Jordan, how long have those cookies been sitting in there?
Oh my gosh, I literally bought them over the weekend.
What weekend?
And this bag, you know what? Then I'll give you your money back. Oh wait, you didn't pay anything for it.
Just for food and all. Dude, I'm gonna crunch it. It's even chewy, bro. I need an extra.
Okay, there was a hole in the bag, but I changed it. You can see see, I kicked it. I slightly ripped the bag. All the cookies that I that is a good question. We're all ready.
For this one? Or do you want to do that? Or this one?
No.
Two is that.
That was arguing. That was arguing.
If you can't find that, you can't find that.
Extra one? I see three. I see one more.
Okay, listen, I need to tell you which one is open and which one is closed. This one is open. You can just barely, this is a sucky copy. This one's open and this one's open. You can just barely see the light coming through, you know? Okay?
They're open.
Yes. So the origin is open here and the top circle is open here.
Does that make a difference?
It will. Not on the first couple, but eventually it will.
So this doesn't make sense.
Yes. Plugging in. No. You're doing the limit in the middle and then plugging into the outside.
Miss Warner, I don't get part 11 or number 11, all the parts.
Okay, have you tried it?
If it's an open circle, you don't have anything.
Okay, so if I'm doing the first one for you.
No, I'm sorry.
I do. She asked for one, so I'm giving her the set.
Can you do F of
Okay,
an open circle?
focus. You can, but you have to pick the closed circle, not the
I'm saying if it's an open circle, it's asking.
then it'd be undefined. Okay, say you're doing this one. You want the limit as x approaches 2 of g. So we'll do that in a second. So look at graph G as x approaches 2. 2 is here. What's my y value? 0 and 0. So it's 0. Then I take 0 and I plug into the outside function. So if I want f of 0, will I pick the open circle or the closed? No, closed. This is an open circle, so I want f of 0 basically. The middle came out to be 0 and then I plug that into f. It'd be -1, correct.
Okay, so the limit goes to the inside.
Yes, the limit applies to the middle and then you plug into the outside. Okay, so the first one, just to make sure you don't do all these wrong, comes out to -1. Okay, you take x approaching 2, you apply it to the middle. So it's the limit as x approaches 2 of g of x. And then you have to plug that into f. So f of 2 is 0 over here. I'm sorry, g of 2 is approaching 0. And then it's f of 2. Oh, wait, hold on. 0. Yeah, which is here, when you're looking at your choices, we said this one is open, so you would pick the closed one. No, because remember, you apply the limit to the middle. The outside is not a limit anymore. So look. No, I think I know what you mean. You're saying for x, for f, right? That it's going different directions? Here? Remember, you're just looking at y value. So as I cover this side, what y value am I approaching? And then this side. It's the derivative or the slope that's undefined. Okay, Olivia just brought up a good question. Okay, remember that, does it matter that it's a V or a corner if you're looking for a limit? No. Yes. I love to help. We're going to do ones like that next week, but you're setting the original.
I think you just plug in the zero to the closest.
Because it says differentiable, so that means the derivative must be equal. And you'll have to do a substitution on the right.
It's in the right and left.
But it's only the right side. You have to be careful. Oh, cosine of 0 is 1, f of 1 is -1. Yes. Because we're at 1, what's your value approaching? Yes.
So how do you also limit into like
So think about what's the cosine of 0?
oh
1. And then you're going to find f at, so f at 1.
So you know it's like I know you said
You are still doing the limit, but think about cosine's continuous. So whatever f of 0 is, the limit's going to be 0 too, because it's not like a step graph where it's all split.
So f of 1 is negative 1?
Correct.
What side of
Wouldn't be the because the limit only applies to the middle. So you're taking the limit on g. Does the limit exist for g? What do you get? 0, right? And then you're plugging in 0 to z. So at f of 0,
Oh, that's
you
just
can take it out.
Is
The limit goes to the middle function.
that just after just sort of
Yep.
I just know what you said.
Okay, we're running a little low on time. Finish those last few.
from the right?
Okay, check them when you're ready, but don't cheat.
Wait, it would be f here. Oh no. Why is it f of
The last one's super psychotic.
and the other one is 0?
Yes, I'll be in Miss Jen's room probably. If I'm not in.
I can do Miss Infinity.
Oh, we got 1 minute left.
Okay, x going to infinity is an asymptote. So as x goes to infinity, what are your y values?
4.
No, they keep going to infinity, so it'd be easier. Now, if it was this one and x is going to infinity, what are your y values?
Negative 1.
You want to fight?
So,
But x to infinity is the definition of a world.
so it doesn't exist because it keeps on
If it's not approaching a certain value, it's not
Yes,
going
I've been trying to, but I need to study it. Big gift for acting. Hey, you want to join?
okay.
Why are you laughing at me?
We're actually close.
It means that this one doesn't exist.
That's like,
Or my chance.
this is for Austin, but yes.
Because
Like,
remember
that's
that
the practice
your
here,
left
yes,
and
it's
right
practice.
You guys
hand
actually
Yes, why are you laughing? Oh my god.
I love everything. You know that.
Yeah, this is
that's
so
why the
hard.
limit is x approaches. Remember that these two must be the same.
It's good, like, you know, for exercise, I'm like,
So this is
okay, exactly.
this little negative here means that you're
Not a-
approaching it from the height in this side of the graph. As I approach from the left, my y wave is 2. But as I come in from the right, it's staying at 1. So that's why the final is
not a color term because the numbers got so fast that it's got asthma.
And then I did the first problem. It's just there's a video of it. I might not have sent it out, but it's on YouTube.
Do I have to
This
show
one
you?
is together.
Thanks for telling me.
These two questions you're going to do. You need to talk to
So how far
the
is it? What do you have?
front.
Oh,
And then we're gonna grade this.
Fun. Kawaii.
She showed me a picture.
It's there. Bro, you should have went
Being inappropriate to think about this is in gallons per hour.
on your
So when you integrate that, you get gallons. That's gallons already.
Bro, score mine. I ran.
Rosalind, you
A band?
Just
kick my backpack?
What?
Oh no.
Thank you.
Just ran.
Have the best day. Have the best weekend. Make good choices. Good luck on your mock exam.
Have a good weekend.
Because it's only from the right. That's what the plus means. And then if it was a minus, you'd only be checking from the right.
Miss Joyner, for the quiz, I have a question. If it's backwards, does that do anything? If like I know that usually the smaller number is supposed to be on the bottom, but it's like
Just keep it all the same and it works itself out. You can reverse it and change the sign, but a lot of times it just makes it more confusing. So I would say only reverse it if you have to. If you have numbers, they'll work themselves out to be the right sign.
Okay, and like this one.
This is great. This is great. You just need to do the interconnective. So if it's x to the minus a half, you'll add 1 and then divide by that new exponent.
Okay.
But you're on the right track.
And this one.
You have to do 7 to do part B. But Kelly, if you want to stay in here at lunch, you can.
get my service on.
Okay, or next week is fine.
Miss, like, I want to stay. I have questions.
Yes, sir.
To go. The line's stupid long.
Sure. Bye. Have a good weekend. So x to infinity is a horizontal asymptote going to the right. Because x is going to infinity.
is it
So look at your
cafeteria?
graph of g. As the x's get bigger and bigger and bigger, what are the y
But I would
values?
suggest
Are
that
they
you go
approaching a
right
specific
now, the
value?
line, you can wait like 10 minutes in there.
No, they're just continuing to get bigger. So that means that your limit doesn't exist. Versus, what if it was f going to infinity? It would stay at -1. That's right. So if x is going to infinity, that's an asymptote to the right. If it's negative infinity, that's an asymptote to the left. You're welcome.
And today I get to go to a fancy restaurant and eat steak.
Ooh, fun.
It's expensive too, you know. Full adult.
Who are you going with?
My family